Now what do you see?
Your handwriting.
My handwriting.
Yes.
Okay, let me get this out of the way. You see my squiggle?
Yes.
Yes, sir.
All right, now I should get rid of my scribble. Okay. All right. Take a look at it. Does that look okay? Feel free to tell me if you don't like something. I'll just repeat what I did here. I did the first, which is x, times 2y dy dx, plus the second, which was y squared, times the 1 dx dx. Then I went minus, and I put a bracket to separate, and oh, my pen quit writing because I hit the star. I want pen. Okay. The first was x cubed. Dy dx is the second, plus the y times 3x squared dx dx equals to 0. Does it look okay to the average bear? So I need to clean this up. So 2xy dy dx. Remember we used to write just y prime to make it easy? Plus y squared, distribute that minus x cubed dy dx, distribute again, minus y, minus 3y, how about I fix that up, 3y, x squared, doesn't matter the order, still all equal to 0. Now what's the secret when you have all these things on one side and you really are looking for dy dx? Anybody, yell it out. While I do it. Well, this is what I'm thinking of doing. I'm thinking of keeping this term and this term on this side, and I'm going to take this term, take it over here, and take that term, take it over here, because they're in the way. So when I leave the two dy dx's, I can factor out the dy dx. That leaves the 2xy. And that also leaves the minus x cubed, I think. And on the other side, I had moved the y squared as negative y squared, and I moved the minus 3x squared y, so I'll make it plus 3x squared y. And then we're one step away from having, let me say, I need to add more room here. Oh, there. And so dy dx would be the right side all divided by what was next to dy dx. That's the 2xy minus x cubed. Now, that's my derivative. Is that what he said it's supposed to be? Let me scroll up. 3x squared y minus y squared. Do I have that? 3x squared y minus, yeah, the order is just different. 3x squared y minus y squared, that's what he had. 3x squared y minus, and then he has 2xy minus x cubed, 2xy minus x. So it looks good other than changing those two around. So what you would say to the reader, you go, check, you know, it looks good. You can move it around if you want. You want to make it look exactly, but it's the same. Now B, find all points on the curve whose x coordinate is 1. So every point on the curve where x is 1, and write the equation of the tangent line for each of those points. So my guess is if I plug in 1 into the function, I may get more than one y value. I might, and I might not. So where can I can't go to the right. It's not like my tablet. So I'm going to have to just write the equation down there again. Maybe somebody could read it to me because you're looking at your paper. This is B. So somebody read me back the equation. It was
xy squared minus x cubed y equals 6.
Thank you very, very much. And he said, I want the x part to be a 1. So I'm going to plug that in and I get 1y squared. So I'm going to just write that as y squared And then minus 1 cubed, that's still going to be 1. That's going to be a y. And then equals to 6. That's a quadratic. So I'm going to have to get everything on one side. So y squared minus y minus 6 has to be 0. And that factors. Is that equal to 0? I think it's going to be a y minus 3 and a y plus 1. No, 2, I mean. Y minus 3, y plus 1, plus 2. Keep saying that. That's going to give me a negative y in the middle and a negative 6 on the out. So I'm hit more room. So my other y's are going to be, y can be a 3 and y can be a 2. So those are your two ordered pairs. 1, 3 and 1, 2. Was that all he was asking for? Was just tell me what the points are going to be? Find all the points. Yeah. Oh, no, I didn't find the equation of the tangent line. Hello. Okay. So I needed those points. To do the equation of a tangent line, this is a very good review for you. To do the equation of tangent lines, you need to have the slope of tangency and you need the point of tangency. Well, these are the points of tangencies. So I'm okay because in each of these points, I have a y1. That's my y1 for that point. That's my y1 for that point. This one is my x1 for that point. And then this is my x1 for that point. All I'm missing is the slope of the tangent line. Well, the good news is he gave us the derivative in the original problem. He said the slope, which is equal to dy dx. Go ahead, somebody, read me what that fraction is going to be. You going to make me scroll all the way up, or?
3x squared y
3x squared y
minus y squared
minus y squared
over 2xy minus x squared.
minus x squared. So there's my derivative. All I need to do now is find my slope at the ordered pair 1, 3. So that's going to be, I'm going to plug 1, 3 up in there. So 3 times 1 squared is 3, and times the y, which is a 3, minus y squared, which is a 9, over 2 times 1 is 2, times the y, 2 times 3 is 6, that's a 6, minus the x squared, I think is what she said. So that's going to be a 1. So the slope of that point is 0. I hope. Anybody agree with my math? It's okay if you disagree with me, because I could be wrong. No comment? I can't see thumbs up or any chats, so you have to just yell at me. Okay, no one's yelling. I'm going to take the answer then. I'm going to have to just call it, that's what it is. So I can make my equation of that tangent line. It's very simple. That equation will be, remember, here's what you always need to remember. Y minus the y1 equals the slope of the tangency that we just found times x minus x1. And you should spell all that out. And I already identified x1 and y1. So y minus 3 has to be a 0 times x, and this is kind of ridiculous. X minus 1 doesn't really mean anything because I'm multiplying it by a 0. So y is just a 3. Okay. So we're doing this in part B, right? Did I even label it as part B? Yeah, I did. All right. So let me do the other equation line. That's going to be the slope at the ordered pair 1 comma, was it 2?
I think
Am I
it's
writing? So it's the same equation. Y minus y1 equals the slope of tangency, which, by the way, is going to be different because we're going to be plugging in different x's and y's. X minus x1.
I think it's -2.
What? Oh, you think so?
yes.
I didn't write it up there then, did I? Thank you, though. You are a lifesaver. So let's go ahead and see what we can do with this one here. We get more room here. I need to do the slope again. Let me scroll up a bit and see the equation again. Wow, it's too big. Can you give me the slope again equation, Danielle? You gave me before. The slope equation was the
3
answer.
squared y
3x squared y
minus y squared
minus y squared
over 2xy minus x squared.
minus x squared. So now if I do the slope at that new ordered pair, which I was corrected, it's 1, -2. So that's going to be 3. They both were 1. That's right. So I'll say, why is it a 3 times 1 again? 3 times 1 squared times the y. That's going to be 3 times a -2. 3 times a -2. This time I'll write it out because I forget it. Minus y squared, which is a 4. Because -2 times -2 over 2 times 1 is 2 times the -2 is a -4. So this time I did it. I don't know why I didn't do it last time. Minus the x being squared, which is just a 1 again. So I hope -6 minus 4, -10 over -5, which is a beautiful 2. And if it's not right, if anybody finds the mistakes that I make, you know what you get. You get points. As you know, I always make mistakes. So that equation, that line is going to be y minus the y1, which I identified it to be the -2. Is that right? So I put a -2 here. It really becomes a +2. So I may as well get rid of it. +2 equals to that slope of 2 times x minus 1. And by the way, guys, I'm not going to mess with this. What happened? I don't know why that was a weird thing. You probably can't see it, but I just got like a pop-up of emails and I didn't know why it's come up. I must have hit something. You didn't see it because it wasn't the screen I'm sharing. I would leave this equation exactly as it is. Don't risk being wrong, okay? This is just a wonderful problem. That is an excellent problem. And it took us long enough because I was down for 10 minutes. C says, find the x-coordinate of each point on the curve where the tangent line is vertical. What does it mean to be a vertical? I'm going to make a little comment up here. A vertical tangent line happens when dy dx, I'm going to just write on top of it, dy dx is what? Undefined. That's my note. Now, if you want to write that in part C for the reader, that's great. So I'm just making a note up here so I can see this. To be undefined, this piece would have to be 0. Okay? So let me go down there. What will I write to the reader? I'm going to write for part C, we're doing, he's wanting to know where it is. Where is the slope? Undefined? Is that how? I don't know how. I can't remember how it was written. That happens when the denominator of dy dx is equal to 0. So what was my denominator? Refresh my memory. What was my denominator? Was it 2xy minus y squared? Is that what I heard Danielle say 100 times? I wrote it somewhere. Well, it's right here. 2xy minus x squared. I was close. So thus, 2xy minus x squared has to be 0. You following me? Hello?
Yes.
Yes, sir.
So there could be a lot of points. So make an equation out of this thing. might be easier to solve this for y because I don't want to take square roots. So add more screen.
I think it's x cubed for the denominator.
Yeah, it was x cubed, not squared. Thank you. Oh, thank you very, very, very much. X cubed. So I'm going to solve it for y. That'll give me, bring the x cubed over, divide by whatever's not y, 2x. That's interesting. What does that become if I simplify it? Isn't that x squared over 2? So that equation is where you'll have undefined. Now let's see, what do I need to, there's got to be something else in the problem here. Go all the way up. Find the x coordinate. Guess I have to substitute that into my original equation. What a mess. Okay, I'm going to need your help because I can't see it up there. I'm scrolling back down. What was my original equation for the function?
xy squared minus
xy squared minus
x cubed y equals 6.
x cubed, oh, wasn't that bad, equals 6. So y is always going to be this to be undefined. So I'm going to substitute that right here and right here. So I'm going to have an x times an x squared over 2. And I'm going to square that bad boy minus this x cubed. And then the y again is also x squared over 2 equals to 6. I'm going to find out what x's will give me this. This gives me x to the 4th times x. Wouldn't that be x to the 5? And then 2 squared is 4. X to the 5 over 4. And then I've got over here minus. Again, looks to me like x to the 5 again. Am I right? But now it's just over 2 equals to 6. So I have 2 of the same things on the left. So common denominator. Let me change colors. Can I change colors easy? No, I can't because I can't see my pens because I'm sharing the screen. Oh, well, I'll keep it. I could set it up to be a clicker on my pen to change color, but I don't want to make it complicated. This is going to be 2 over 2 to get a 4 down here. So 1 minus 2 would be a negative x to the 5 over 4 will have to be equal to, that was a terrible 6, equal to 6. That gives me negative x to the 5 equals to 24. I've got to take the 5th root both sides. And that's okay. You can take, that gives me a negative x because the 5th root is odd of a negative number is still going to be a negative there. Is the 5th root of 24. I don't care what it is, guys. This is free response. You don't have to be detailed. I'm going to leave my answer as the x is the negative 5th root of square root of 24. That's what he wanted. He just wanted the x coordinate, I think. Wow, I wrote a lot. Yeah, he just wanted the x coordinate. That's a lot of work. But there was a lot of good stuff in there. You've done all of it, but in bits and pieces. It's different when they're giving you a full problem. All right, let's see if we can find something else that we can work on. Another good one. Another good one. You want to do another one of these? Or want to look at something else? I think I did this one in the video. Speak now or hold your peace. You don't care.
I'm good with whatever.
Whatever. All right, let's do it then. A says write the equation of the tangent line. Okay, good review again. We just did one. To do the equation of the tangent line, you need the slope of tangency, and you need a point of tangency, which he gave it to me. He gave me the negative 2, 1. And I have the slope. I know that slope generically is just the negative of the x plus 1 over 2 times the y cubed plus 1. But I need to do this at the point negative 2, 1. So my slope at negative 2, 1 is negative. And if you do stuff in your head, you're allowed to. You don't have to show everything. But sometimes there's no calculators allowed. So you got to get used to some method. X plus 1 will be a negative 2 plus 1. That'd be a negative 1 over 2 times. Now, y squared is a 1, or y cubed is a 1, and 1 plus 1 is 2, so I have a 2 in here. So I think I have a positive 1 over 4. So now I'm ready to make my equation of the tangent line, because all I need is my y minus y1 is my slope of tangency times x minus x1. Don't simplify. Just plug everything in. Don't waste your time. So y minus the 1 will have to be that point of tangency, which was 1, I mean, the slope of tangency is 1/4 times x, and the y was a minus, or the x is a minus minus 2. So that'd give me an x. What did I write right here? Oh, it's minus x1. So that would be a minus minus 2. That would give me a plus 4. And stop. Leave it like that. That's all you had to do. B, right? Did I do A? That was it. All right.
You were working on B.
What's that?
You were working on B.
I didn't prove the derivative. I'm not going to do that one because we just did one like that. So we'll just pretend we got it. Because you're going to have to just go left to right. And that looks exactly like what we did. We have a product rule here. I think this one's actually easier. Now, if somebody wants it worked out, yell at me now before I move on. I want to go on to C. Let me write over here. That was B. Nobody said nothing. Okay. C. Find the coordinates of the 2 points where we just did that one a minute ago. That would just be find where this denominator, again, is set equal to 0. Okay? Do you need to see it again?
Yes.
Okay. So if I'm doing C, I want where is there a vertical tangents? That only occurs, remember, vertical tangents is a vertical line, and the slope of a vertical line is undefined. So we know that if that happens when your denominator becomes 0. So I may as well take my 2 times y cubed plus 1. I have it written right there as well. So this occurs at 2 times y cubed plus 1 set equal to 0. So you can make another note. You could say denominator equals to 0 of the derivative. I can't write. It's over to the edge of my screen. So here goes. Let's see. I only have one variable. So it looks like y cubed is equal plus 1 is equal to 0. It was y cubed, right? I divided both sides by 2. Y cubed equals to a negative 1. Take the cube root of both sides. And when you take the cube root of both sides, unfortunately, you only get one answer. You only get y is the negative 1, because a negative 1 times a negative 1 times a negative 1 is still a negative 1. So y is 1, but what is x? I don't know. I'm going to have to take my equation that we have written up here somewhere. That's the equation here. And we're going to have to plug in the y value that I got. I need someone to tell me what that equation is, because I'm moving down. So my equation is, for the equation, somebody give it to me. What's the equation? I know it started with x squared, didn't it? Or is it x cubed? I think it's x squared something.
So do you want the entire equation?
The entire equation.
It would be negative parentheses x plus 1.
Not the derivative, the equation.
Oh, okay, okay, sorry. X squared plus 2x plus y to the fourth plus 4y equals 5.
Reason I don't remember is because we didn't prove the derivative. So, all right. So now if y is 1, I can plug it in. I get x squared plus 2x plus 1, because 1 to the fourth is still 1, plus 4 times 1 is 4 equals to 5. And so the left,
It was a negative. It was a
oh,
negative.
thank you. That becomes a plus -4, right? Thank you. So what that turns into x squared plus 2x minus 3 equals to 5. That's a quadratic. You're going to have to get everything on one side in order to solve it, always. So bring that 5 over. So I'm looking at x squared plus 2x minus 8 equals to 0. Does that factor? I hope it does, because it would be fair if I have to use quadratic formula, not when there's so much in this problem. X and X. I think 4 and 2 will work. If I put a plus 4 and a minus 2. Yes, X can be a -4 and X could be 2. So those are two ordered pairs. So it happens, vertical tangents occur. Is there 2 R's or 1 R? I don't know. At -4, -1, and 2, -1. That's a good problem. I'm glad she wanted to see it again, because it's very, very, very probability you're going to have to do stuff like that. This implicit stuff is going to definitely be on your AP exam. Okay, so that was CD. Is it possible for this curve to have a horizontal tangent? I don't know. How do I prove it? Well, just a side note up here. A side note. Horizontal tangents occur when? When the derivative is 0. So my derivative, who was helping me? Was that Annette or Alyssa? I don't know who was reading to me a minute ago. Hello? Who was reading me the equation before?
Oh, it was me,
Who was me?
Susanna.
Susanna. Okay. Susanna, read me the derivative again. So dy dx, you started reading the derivative, right? Was, you said negative.
Parentheses x plus 1.
Okay, 1. Okay.
2 parentheses y cubed plus 1.
So what happens here, if I'm going to set this thing equal to 0 to find horizontal tangents, and I multiply both sides by this denominator, doesn't it go away? So the truth of the matter is, I only really care about when the numerator is 0. So really, I could have said horizontal tangents occur when negative of x plus 1 is 0. That means x plus 1 is still 0. That means x is a -1. Now, you might be happy, but you just said it happens at x equals to a -1. What you don't know is you may not get full credit because you don't know what that ordered pair is. So let's find out what the ordered pair was. If Susanna, if you could be so kind again, is to read that doggone equation again to me. For the equation, the long equation.
X squared plus 2x plus y to the fourth plus 4y equals 5.
Let's see what happens when I plug in x as 1, because I want to find the ordered pair. I'm not really sure what he asked. If he asked me find it, or did he just say, is it possible? Oh, but he does say something else in the problem. Let me go back. I do have to go up and look at it. He said, is it possible to have a horizontal tangent at points where it intersects the x-axis? Okay, so let me just look. Let me look for it and see if it does intersect the x-axis. If x is equal to 1, and I plug it in, I get 1 plus 2 plus the y to the 4th plus 4y equals to 5. The problem is I don't know what y is to plug in. I'm going to get this really ugly equation. Well, I do know what y is. Y must be 0 if it intersects the x-axis. Why is that true? Because look, you got a graph and it crosses the x-axis, then y is 0. So let me finish this up. 1 plus 2 is 3. 3 plus 0 plus 0 equals to 5. Oh, wait a minute. What happened? Where did I make a mistake? Or what does this mean?
So did you plug in x equals
X was 1 right here. 1 squared plus,
It was
wasn't
a
it negative
negative-
1?
I don't know, was it?
Or I thought that's what it was.
I could be wrong. Oh, yeah, okay. Let's fix that. That stays the same. This now does become -2. Okay, so that changes into 1 minus 2 is a, let me get rid of this here. -1 plus 0 plus 0 equals to 5. Well, that didn't help either. What does that mean? That means there's no ordered pair. There is no ordered pair of 1, 0. And x had to be 1 because we solved it by the numerator being set equal, where was it at? I did the numerator right there. When I solve the numerator set equal to 0, that gives me x equals something. That has to be the x coordinate. And we got x equals to a -1. Yeah, we certainly did. So x has to be a -1. And when we plugged -1 into the function, it didn't exist. So you could get a lot of points if you didn't prove that. If you stopped up here at x is -1, you probably still got a super lot of points, but you don't get full credit because you should look for that point and see where it is. And it's not on the graph. An ordered pair 1, 0 exists on the curve. Wow, what another good problem. I don't know about you, but to me, this is kind of like, this is fun. Just randomly picking some problems and seeing, oh, we did, which one did we do? We did that one. Gotta keep going. There's another one. It looks like more of the same stuff. I don't want to take all the fun from you. Is that the same? It's not the same. Okay, what's happening here is after we do all that implicit stuff, the lesson starts into talking about related rates. How much time do I got? I got less than 20 minutes. I got only 13 minutes. Do I want to tackle a related rate problem? Let's see. Good homework you could have done, but I'm not assigning that to you. If you do it, I'll give you all the answers. If anybody does any of these extra assignments. Let's go to here. I'll bet you this problem has to do with related rates because it came after related rates. Let's do this problem here. It looks like the same stuff we were doing, but I can see at the bottom, I see some dy dt's and dx dt's. That's related rates, if you recall. So I think we owe to get through this problem and then we can call it a day. And then I'm going to point you to the quiz or a test that's in that packet is what I want you to work on. Because it accumulates a lot of stuff you've already had. All right, somebody read me that problem. Consider what curve?
Consider the curve by y squared equals 2 plus xy.
And A is asking us just to prove a derivative. Are you convinced I don't have to prove that derivative again? Because we've done that already several times today. Well, we only did it. Maybe we did it twice. You want to do it again? Class? Nobody cares? You got to be brave like Danielle. If you really, really, really want to see it, you need to say, yes, I want it. So I'm going to go do it real fast here. I'm going to do it. I'm going to do the derivative right now. 2y, I'm going to cheat, y prime. That's it for that, please. Equals, what am I doing? Equals 0 plus product rule. The first times y prime plus the second times x prime. Okay, so that doesn't look too bad at all. I have two terms that have y prime in them. Let's put them together. I'm going to now put it back to dy dx so I don't get confused. Minus x dy dx still equals to a, what was my last part? It was a y times, is that one right? It was the, I'm looking up here, first times y prime plus y times 1. What did I write? Nobody said anything.
Correct, but I think it's just switched. Right?
It should just be a y, right?
Yeah, it should, yeah, 1.
So it equals to just a y. Is that right? Somebody tell me. I think so. So then I factor out, like I did before, I factor out the dy dx. Oh, I was thinking of related rates. I want to start doing x dx dt and dy dt. Yeah, and that's 2y minus the x equals to y. So I'm getting, I'll put my arrow here so I can save some space, that dy dx should be the y over the 2y minus x. And I cross my fingers and I look up, hey, 2y minus, I got it. Okay, so we put a big check mark and a smiley face and let the reader know, hey, I got that. Now, B says, show all the points that are tangent to a half. We haven't done one of those. Show where the slope of tangent lines are a half. So I'm going to take my derivative for B, and I'm going to take my derivative, which was if the slope is always y over 2y minus x, and I want to set it equal to a half because that's what I want to show. And that's just a fraction equals to a fraction. So just cross multiply and divide. 2y equals to 2y minus x. Does that look okay? If I move this 2y over, I think I get a 0 equals to a negative x. Bummer. I think I get x equals to 0. Well, that doesn't mean it's not possible. X can be 0. But what I have to do now, I have to go back to my original equation, which is, I'm going to need someone to read that back to me. Y squared equals 2 plus xy. Maybe I remember it. Hold on. I might remember it. Y squared equals to 2 plus xy. Yeah, I got it. So if x is 0, that goes here. That gives me y squared just equals to a 2. Y's must be plus or minus the square root of 2. So there's two y's. So there's one x. So your two places are 0 square root of 2 and 0 negative square root of 2. So there's your two places where the tangent lines equal to a half. C, what does C say? I won't do this one because we just show that there are no points that are horizontal. We just did one like that where we found out there was nothing, the point didn't exist. Let's jump to D because there's your related rates. Let x and y be functions of time t. Okay, so now we're looking at x of t and we're looking at y of t. So there's two functions, x, y, and another variable called t. So that's how you know it's related rates. And it's the same equation. And now we're saying at time t is 5, we know that the value of y will be 3. And at that same time, we know that the derivative with respect to t of y, dy dt, is a 6. What is dx dt at that same time of t is 5? So let me write the equation. Y squared, this is going to be d. This will wrap it up here. Hope you're enjoying it like I am. I'm having fun. Y squared was equal to 2 minus xy. Now, with respect to time, so it's 2y, not dy dx, but dy dt, equals to 0. Product rule, minus what?
Zeros plus.
Oh, thank you. Well, then that really saves me. That makes it silly of putting the parentheses, but I'm going to leave them there because I'm in a hurry. The first times the derivative of y with respect to time is dy dt, plus y times the derivative of x with respect to time is not dx dx, it's dx, 1 dx dt. So there's my related rate equation. Now remember what he said. He said at t is 5, he said that y was equal to, what did he say? Y was that the 6 or was that the 3? Y is, one was 3 and one was 6.
3.
3. And the other one was dy dt was the 6 then. And then we're looking for what is dx dt. That's what we're looking for. So plug everything in. 2 times 3 times the 6. I'm just copying this right up here. Equals to, there's a 0. The x, I don't know x. Let me just write it down. X dy dt was 6. Plus the y is a 3, and this is what I'm looking for. I don't have the x. I have 2 unknowns, so you need another equation called a secondary equation. Let me see here. If I go to my original equation, yeah, I think my original equation, can someone read me back my original equation? What, I don't remember what it was. Was it y squared? Was that y squared minus 2xy? Or y squared equals? It was y squared equals 2 minus xy, wasn't it?
Y squared equals 2 plus xy.
2, I keep writing minus, plus. So if I know my y is 3, if y is 3 at t is 5, then I can solve it to find out what x was at 5. So that's going to be 3 squared is 9 equals to 2 plus x, I don't know right now, times the 3 gives me 7/3 equals to the x. So there, okay, I got my x now. I can plug it in right here. Okay, we're almost done. I can feel it. 2 times 3 is 6. 6 times 6 is 36 equals to 7/3 times 6. Help me out. 7/3 times 6. The 3 goes into 6 twice. That'd be 14. Yeah, because 7 times 6 is 42. 42 divided by 3 is 14. It is. Thanks for helping. Come on, guys, help me out. 3 dx dt, which is what I'm looking for that I don't know. Almost done. 36 is equal to, no, 36, let's do 36 minus the 14, all divided by 3, is dx dt. And that gives me 22/3 is dx dt. So you always, I'm cheating, you got to really tell what that means. You got to say, finish it up. And this takes me to the end. At t equals to 5, the rate of change of x, which is called dx dt, is 22/3. Now there's no units, so this problem was just this generic thing in space. There was no inches per minute or nothing like that. Okay. Questions? Let's scroll down to the rest of the slides. What I want you to be working on through the weekend. Those are good problems. I should have you do those, but I'm going to take you to here to the major. This is what I used to give last year all the time. Here's how the test works. You start out with a calculator portion. There's 8 multiple choice questions. There's even a rubric of how I grade it. So you got 8 multiple choice questions. And once you finish those 8, there's always, okay, you might not remember how to do this related rate problem because that's my next lesson will be related rate again. But you just did a Khan Academy related rate, so I think you can do this. But you have one for a response. Well, this one has 2. It's weird. Most of the time I only had 1. Maybe this one even has 3. I can't remember. No, I think it only had. That's all there wasn't. I want you to work on this. I think that's the whole test. I hope. That's all I gave you. And it's not due. What is today? Wednesday? Work on it, as soon as you can, preferably if you can over the weekend, be fine, but I'll be assigning you more stuff. And watch the video I'm going to post because I think I do a couple problems or I say something. I don't know. I think I did a lot of the same. Let me quit sharing so I can see your wonderful faces.
Sorry, I have a question.
Yeah.
Wait, what's due Friday?
There's really nothing due. I'm going to be posting answers to the stuff you've already done.
Okay, so we just like work on the